And therefore, b equals a plus h, making our equation r m equals f a plus h minus f of a all over a plus h minus a. Now you might say, Mr. Sadler, why do we need this? And this goes back to what Peter and I were talking about yesterday. Peter, remember we were talking about a tangent, and you were saying it's 1 point on the graph. And I said in calculus we can't do that. You can't find the slope of 1 point. So do you remember what I said, how we tried to do this? So what we're going to do here is we're going to just do the same equation, but we're going to make h0. So the gap between them. So I'm going to keep on writing this as f of a plus h minus f of a all over h. To find the instantaneous rate of change, h equals 0. Now this is the magic of math, okay, because we're going to have to do some algebra here. And I don't see a problem with making h0. It should hopefully be like alarm bells being warned here, yes. You can't divide something by 0, so we're going to cheat. What we're going to do is we're going to do our algebra and make sure that divided by h cancels out. Okay, that's what we're going to do. All right, so we're going to do some good algebra first and make sure everything cancels, and then we're going to sub it at the end. It's called cheating. It's also called instantaneous rate of change. Yes?
What did you do from that first line to the second?
Sorry, so thank you. All I did for this, I just expanded the brackets, right? A minus a cancels, right? Just with h. Okay, let's do a few examples here. Do we get sort of what I was trying to do there? I was just trying to show that equation comes from Robin. This isn't 8 days a week of swimming. We need you actively here. How you doing? This is tough. This is deep. This is deep. But once we see the magic here, the first half was awful. The second half of this lesson is beautiful. Here we go. So, example 1. Find the instantaneous rate of change. Of f of x equals 2x squared at the point 1, 2. Okay, let's do some algebra. I'll take this one gently, then you guys can attack the next question with your giant brains. All right? Sorry, I'll go with that. Okay, so what we're going to do is we're going to sub. I'll give you a second to write down. I'm too excited here. This is awesome stuff. So I'm going to sub into the equation. Can I get someone be brave to recite from memory or from the page what the equation we're going to use today is, please, for instantaneous rate of change? Alana, go. Great. Okay, now here comes back to grade 10 or grade 11 or earlier this year. Can someone be brave and tell me what f of a plus h is going to equal? Go ahead.
F of b.
Yes, good. Excellent. Wonderful. But that wasn't what I wanted to say. What I was hoping, if this is x, I just want you to sub it in here. So I was hoping you would do this. But I love your enthusiasm, though. That's good. Okay, so you see what I did there? Thank you. That's good. So what I did was I just subbed in a plus h, and then I'm going to subtract that from 2a squared. So I'm just doing the substitution. So this is the same thing we were doing with the average rate of change. Like this, I'm just doing this. That's all I'm doing, right? So I'm subbing half of this, but I'm using a general equation instead of numbers. That's the difference that we're doing. wonderful life. What's that?
Like, why are you putting 2 there? Like, I know it's 2.
Just here, right? 2x squared. So f of a plus h is 2. The 2 is there. Everywhere you see an x, you plug in an a plus h, right? And then squared at the end. Okay. All right, Owen, I'm going to pick on you. What is a plus h squared equal to, please? How do we do that?
So it's just like having 2a plus h side.
Okay. Okay. I'm going to do that quickly because I want to get to a few examples today if I can. I shouldn't rush. If I need to do some of this tomorrow, I can do it tomorrow. Okay. So I just multiplied the first 2 in. Is that a question or is the scratching there? Scratching is okay. So I mentioned I used to have a girl in my class 2 years ago that sat in the background. She used to do this. She stretched it back like this. And I called on her 50 times to class. And then she was like, this was after I just stretch it. Callan, stretch no longer. Can you please show your filming skills, please? Right now, fill this out.
So 2a squared
Yeah?
plus 2a.
Yeah?
Say right?
Yeah, so this turns this to h, yeah?
And then 2ha plus 2a squared.
Okay, now before that is correct, I'm going to fix up one little thing, because that is technically correct, okay? Can anyone see one thing I might want to change? That is right. Callan, you want to?
2a squared next to 2a squared or no?
Yeah, you can do that, that's fine, but that's, there's one thing I want to do between that and that.
It's 2ha and 2a.
Yeah, because AH and HA mean the same thing, right? So what I'm just going to do is I'm just going to flip these around. Okay, it's time for some good algebra time. Can somebody be brave and combine the numerator and tell me what we get? Does anything cancel? Can I combine anything? What works? Go ahead. Yeah. 2a squared cancel 2a squared. So you end up with 4ah plus 2h squared all over h. Great. Wonderful. Awesome. Why am I happy? I'm always happy. Why am I happy today? Go on. Yeah. Right. If you take a look, I can divide everything by h here. So I'm left with, my equation for slope is 4a plus 2h. That's my equation for slope. Okay, I'm going to take a step back. You guys do a few of these and you'll say this is so easy, okay? What I've done is now I've found an instantaneous rate of change here. Not yet, okay? Because my a value is going to be 1, which is my x coordinate. And h is going to be 0, and that's the difference. So in order to get my instantaneous rate of change, oh, facts right, Becky. I just said 0.1, 2. So I said using the x value from this, that's what I'm going to use. Therefore, the instantaneous this is scary the first time you do this. I'm not going to get into heavy duty stuff like this in this course. I'm going to maybe get to cubic study. You will see things that make your toes curl when you get into calculus. Okay, this should not maybe make your hair curl, is all this will do. Okay? I'm sorry for those people that will straighten their hair. Matt.
How come we only use the x value and y?
Because there's no y values technically in here. Right? So, but the reason, yeah, you don't, because this only involves your x.
So because h equals 0, do you have to write 2h? At the starting, can you make like?
Yes. Now here's the thing. Yes. Because this is the magical thing about this equation. Okay. Let's just say, you know what? I don't want to put the h in there. That's just like f of a minus f of a. What's f of a minus f of a? 0. So you end up with start with 0 over 0. That's the cool thing about this, right? You can get around those little tricks. You have to use algebra to do it though, right? But you can't. So yes, I'm going to definitely say don't skip and don't start slashing stuff when you shouldn't. Okay, it's only right at the last step because h isn't 0 until the very, very end, and that's how we get away with dividing by 0 because it's not 0 in the middle. It's only 0 at the very end. That's it. It sounds, I know, it sort of makes me easy too, but that's how you do it. Go.
So the m equals 4a plus 2h, that's if we keep it where you need to express.
Yeah, just for this individual question.
But if you had example 2 at 4x cubed, then
Yeah.
you know.
Right on. And very good. Yeah, and good point. I should have mentioned that. That's only for this question. Actually, it's only for that question. Yeah.
H is 1 because of that,
What was it? Because that's it. Because the point 1, point 2. Right on.
but the 2 is 0.
Right on. 2, you don't. Okay, I'm going to try one more of these. Want me to take you through another one, Jesse, or do you want to try this on your own? Thank you, Jesse. Here we go, example 2. Find the instantaneous rate of change at, we'll say x equals 2 for f of x equals, oh boy, we'll say x squared minus 3x plus. Okay, so I hit pause on the video. Okay, I want you to try this out. This will be a little bit bigger. Okay, your assignment has big, huge questions. For your test, I'm not going to give you something big. I don't want you to chew up, 15 minutes. You're probably going to be about 6 or 7 questions on your test. I aim for about 10 minutes a question, right? So 7 questions, 70 minutes. That's sort of my goal. I'm not going to give you a question that'll take you 40 minutes to do. It's not fair. All right. On your assignment, I may have accidentally put 1 or 2 that will be big like that. Okay, right. But on your test, something that's squared, you should be able to do. Like something like this should be testable. I hit pause in the video if you need encouragement.